Good morning or afternoon or evening, as the case may be, wherever you are today. I hope that you're all well, given that new waves has just started in many regions. As the title of the webinar suggests, is also mentioned by Ivan, today in this webinar, we are going to look at the importance of AI applications and some of the ways that could help us to create them with less time and effort in organizations. So before we go into the details, I'd like to spend a couple of seconds on numbers and look at a few numbers and see that where we are today and where where we want to go in the next couple of years or in the next decade. Studies by market research institutions show that within the next decade, contribution of AI and machine learning to economy will be as high as $15.7 trillion. And this number, these studies have been, this specific study has been done by PwC. And in that study, they've estimated that these numbers will translate to GDP boost in some region up to 26%, and in Europe that would be 13%. These are really big numbers if you look at the contribution to the AI is going to have in our economy, and in decade means that a couple of years from now. And before we go further, I'd like to also spend a couple of seconds to look at areas where AI can also help us. There are obvious, areas that are being discussed in media, like Terminator type of AI, or autonomous driving. Those kind of hot topics that always we see in media. But there are many different use cases in businesses that basically contribute to that boost that we have just mentioned. In this slide, we're going to see a couple of examples, but by no means they're exhaustive. There are, I'm sure that you know from your own business areas that AI can contribute and improve the current process. For example, here in consumer product market, we know that AI can help us individualize our marketing and services or product offering and tailor them to each individual's need, as opposed to like treating their customers in masses and different segments in principle. And the same would go for other types of business, like in healthcare. The same situation will have instead of mass treatment, like creating drug that everyone is going to consume irrelevant to personal characteristics. The personalized healthcare offering could create a lot of different experience. Even in the time of pandemic we are in, we hear things like that kind of vaccination is going to help us, give us protection in 90% of the time or 95% of the time, even some numbers suggest. But even in that high number, we will not, we're not confident whether I personally, as an individual, are still protected by that or not. So, because they are produced for everyone, and they're not optimized for individual person. So that's the idea here, that utilizing these techniques to offer more personalized healthcare. And in manufacturing, like predictive maintenance, instead of waiting, letting something break down and then fix it, or fix it even before we need to fix anything, as the preventive maintenance would do. AI could offer here to predict the likelihood of a breakdown, so that we can optimize maintenance and the uptime of our equipments. And when it comes to customer service, I'm sure that many of us have here and there have been target of low quality of service, like telecommunications and things like this, that where we needed good quality of internet connectivity, we didn't get that. So by predicting where we need, what kind of service we can optimize these service offering and quality, and make sure the qualities of those services reach the point where every individual being satisfied when they need those kind of services. So these are just a couple of examples just to see that where AI actually, when we are talking about AI, it's not always about these kind of autonomous driving, or those types of AI, but also there are lots of other areas that AI can help and basically contribute to that boost in economy. But the point is that looking to these use cases and the boost in economy, everything sounds good, right? Then question is that what is the casting? This rosy outlook of all these AI promises, we just looked at a few of them, could quickly fade away when we face the when we go and want to implement those, right? So then we quickly face the existing of many current hurdles to implementing and adapting to those AI solutions. And actually, there are many surveys that find out more than 84% of AI projects fail to actually deliver the business outcomes that business really were expecting. And the fun fact here is that also this figure has not changed since the reports that we were reading since 2015. That report from Capgemini is from 2015, and more recent ones, more or less they're giving the same figures. So it means that or it seems basically that we've not improved in recent years to get the business values that we were expecting from these efforts in AI adoption. So the question is that then what kind of what are the problems, how we can solve that? In this webinar, actually, the intention is not really going solving the world's problem, but I'd like to look at a couple of items that we see as hurdle, and look at how we can or how technologies basically today can help us to overcome some of those. And this list that we see here is from a report from the European Parliament. They have brought out these items as are highlighted basically as current challenges and barriers for adapting AI in organizations. The first one, the obvious one, the lack of AI strategies, that's a problem in state level. Governments need really to touch on those. So in the next couple of minutes, we will not be able to solve that. The organization as a whole, and governments, states, they need to be involved to work it out, is really what needs to be done and what kind of strategies we need to solve those kind of problems. But there are other issues that technology really can offer us. If you look at the silos that are existing in organizations, in order to address these kind of problems, we really need to use the technology, or when we are going to adapt technologies, we need to foster collaboration between different units. If you have data science team or expert that building AI, predictive models or AI tools, and then we have business units, we need to be able to connect those personas when we are going to adapt or bring in AI in our businesses. Resistance is not specific to AI. Anywhere when we want to change something, always there's resistance. And in order to do that, to overcome that sort of problem, we obviously need to at least make it less complex. We need to make the changes look at least less complex, reduce the complexity of the technology that we use. And as we know that some of the AI based applications really tend to be very complex. So we need to reduce that in order to reduce the resistance to change in that area. And one of the other items that's mentioned that report is the lack of talent. This is obvious. We don't have the amount of AI expert that organization now are looking at for in the market. And what we need to do here is automation. So why? Because if any steps of these AI creation, if can be automated, we automate. We can utilize the current existing talent in organization that we have, like the amount of the data science team that we already have. They could reach a lot more when we automate many of those processes, and we can speed up bringing those AI projects in life in a short amount of time. And obviously, the last one to address the budget constraints, or when we want to address the smaller enterprises that they don't have a big bucket of those big corporations. The way to handle that is obviously democratization. And actually, if you look at these items that I've mentioned earlier here, these basically, if we sum it up all, that basically tend to democratize these technologies, and even the smaller companies can start using when a tool is less complex and is automated, so they don't need lots of big teams to start and implementing AI-based solutions in their organizations. Actually, when we look at these items, as just mentioned here, they're not new. And what I mean with that, if we look at, when we look at our history, we see that whenever we replace manual labor with machine and automation, we actually change the pace of history, right? So, for example, automating printing by inventing printing machine, as opposed to just copying the books by handwriting. We have been able to democratize knowledge, right? And with that, we had a great impact. We had this, printing machine had really great impact on enlightenment, right? And the same goes for the impact of automation and industrial and manufacturing evolution that we had in the past. What I want to say is that when it comes to AI and machine learning, there's no reason to believe that we're not going to expect the same thing. I mean, if you're going to automate that, and simplify the process, we should be able to expect to see a similar effect that we had in the past. And when I'm saying that automating, I'm not saying that using AI to automate some of the process. The value of this already known, and everyone knows the benefit of it. What I want to mention today is that even creating of AI itself needs to be automated, or no code, or wherever that possible, low code, because sometimes your flexibility requires them. No code is not a way to go. But we need to adapt to low code, meaning that we need to reduce the complexity and amount of effort to create those applications. And if you look at AI now, what AI-based applications are actually, what process we need to do to create an AI-driven application. The first one is obviously to create or make the artifacts, meaning that we need to create a predictive model. The next thing would be to take those artifacts, bringing them into IT environment and running them somewhere, and exposing an API that other applications could use that predictive models. The last step here is to interface those, or expose these models as being created, deployed now to business users using some sort of applications that we call it AI apps. So these AI apps are supposed to create an interface, a user interface to business users, so that they can see the results of these models or interact with them in order to run their daily business tasks. And this one is crucial, and why it's crucial is obvious. The value of any idea, as Thomas Edison put it, lies in the using of it. So unless we use these, it's being used, the predictive models or whatever that we create in business, any effort that we put here is going to be wasted, right? So, and that's one of the problems that we see today in many organizations. And when it comes to automating or no-code, low-code tools, any of these steps need to be addressed, and we need to automate the process as much as we can in any steps that is possible, so that we can have same impact and effect that we have seen in history. H2AR Hybrid Cloud, obviously, aim to bring these steps in that platform and allow organizations to run these steps, or perform these steps in an automated or no-code, low-code way, from creating models, operating them, in an IoT environment, and creating AI application on top of those, and exposing to business users. So actually, with this platform, organization can create what you call it, AI app store, so that eventually at the end you're going to have your own app store that different users can interact with. The focus of today's webinar would be this application creation piece. So the rest of it, if you're interested to know that, how H2AR Hybrid Cloud can help you create the models, deploy them, and those sort of aspects, we have already done a webinar that's available on our website. Please feel free to have a look on those if you are interested to find out more how these steps are done. So for today, we can now spend a little bit of time on these the aspect of creating those applications, and see that how we can run it on H2AR Hybrid Cloud. So in that slide, I'd like to give another view from the importance of applications and why they're important. As we all know, data is a source of information, but itself is not information. So we run analytics on top of those, like visual analytics, or predictive analytics, or those sort of analytics. We run on top of data in order to extract information. And then when we have this information, we need to act on it, or expose this information to different business units, like business analysts, the decision makers, and those sort of personas. And this can be done by applications that we create on top of the analytics that we build. So we created a model, we created predictive models. Now we put in an application to use that and expose that, the results of these models to a decision maker, so that it can get feedback from it or act on it, depending on what, how the prediction was, and et cetera, et cetera. But the question is that, so why we are not just simply go ahead and create applications? The problem is the classic full stack web application development is very code intensive and needs highly skilled developers to develop these applications. So it's not straightforward. Let's say that, I have a data science team or data team, go and develop web applications, because there are different types of tools, there are different types of technologies that typically you don't find those in data science team or data-driven teams, they're like JavaScript and HTML, CSS that typically tend to be different technologies that data science team use. So when we are when we're going to merge this kind of stuff, it's going to be a little bit very expensive and complex in order to merge those and bring the knowledge that needed to create these kind of applications. And again, as I mentioned, this is a very code intensive as well. So we need to, reduce the complexity on one hand, and also using the technologies that the teams that are creating these kind of analytics are familiar with, so that we can create those kind of applications in a short amount of time and with less effort. So actually, H2O Wave SDK is a response to that need that we have mentioned. It is a Python and R SDK to develop or rapidly prototype business-facing AI applications. So in the advantage of using Python or SDKs is that they are kind of the languages that typically you will find in data science team easily, as opposed to HTML, CSS, or JavaScript that really far away from the data science field. With that, data scientists could easily go and quickly, in no time, create their or prototype on the back of the predictive models that they have created, and create an application and expose that to business users. And the entire SDK is very well integrated with HTML platforms, so you can run it on top of HTML platform, and it also supports real-time capabilities for streaming. For when you have a stream data and you want to create monitoring or stream analytics, you would be able to implement those sort of use cases using this framework. And when it comes to enterprise settings, obviously we need a security line or single sign-on authentication, which is also supported by that SDK. This is open source, so you can also go under this URL and start using it today if you like. Another thing that I like to highlight is the following: that the apps that you're creating can be easily deployed on H2A or hybrid cloud. Just one point that, when I'm saying that H2A or hybrid cloud, this is the platform that basically runs all these steps that we mentioned, right? So creating models, deploying them, and also deploying applications on top of it. And it will run, on premise or on cloud, depending on your requirements and where your data sits and you would like to have the deployment to happen. So actually, the platform, when you create our apps, in deploying them, this actually now enables organization to have their own AI app store simply by one single platform. So now have a look on how then Wave SDK looks like and how we can start coding. The intention of today actually is not to go so much technical. However, I'd like to use the opportunity to look at a couple of examples together today, just to you have it a little bit look and feel that how the coding will look like, and how quickly we can get from modeling to an application with few examples, and you get a feeling that how the coding will look like here and those sort of things. What you see here is a complete application, very simple one, hello world. It's a little bit boring, but you get the feeling that how we can start quickly creating an application and running a hello world. So let's have a look together how this would look like if I did it on on my laptop. And now, so this is that example. Actually, before even coding here, I showed the web page of Web. This is web.html. So you can go here and explore a bit more and get familiar yourself what can be done using this web framework. But what I like to also quickly highlight here is that you have a gallery here, that you have a list of different components, elements that you can quickly see that how you can use it, this framework in different create different plots, to create different dashboards or settings, applications, and etc. So what I want to do first in here is this very simple one, hello world. So what we're going to expect to see here is a card appears here and it says obviously hello world. So let's get running. As I mentioned, this is a very simple one, hello world one, but we see that quickly without doing lots of effort. Just this card here, the rest here is just setting the some of these preparing that so that it renders it correctly. But for this element here, what we need is this card to run to show us this element here. This is our first app, not very exciting one, but as you see, I have a web application without doing much of if any at all, HTML, CSS, or those sort of things that you would typically need to do. And I can change it to my second app. So let's save this one, and now I've got my second app. So the purpose of the call obviously is not to create an app like this. This is nowhere close to AI app, but let's together, I'm going to stop this one, work out a very simple example where we get to build an AI application from all these three steps that I mentioned, creating a predictive model that we need as a first step, The second is deploying them, and then finally an interface here that we expose that to a business user. So if everyone ready, let's go with the first step. What you see here, it's H2AI Hybrid Cloud. Actually, that runs on the cloud now, but if you run it on your premise, you're going to have the same, same application, same platform as you see here. This is the landing page where you see your app store. And these are applications that's been created by H2O team. But again, as mentioned earlier, you would be able to create your own and have your own AI app store. So let's quickly go and create the first model here, starting right from the data. I'm going to steps a little bit quickly, these steps, because that's not really the purpose of the webinar today. It's again, as mentioned, if you would like to see how to create these in more details, we have webinars related specifically to Jolas AI, how to create models. But what I want to show you today is quickly how we can create a model, just starting with the data like this. So this is a churn data. So for those of you that are not familiar with churn is like predicting whether a customer of us is going to churn or leave us to a competitor. So this is a data set from a telco. What we have is obviously telco customers. Their data set, their demographic data, the type of products, the services they use, the price they pay, etc., things like this that you would typically have. And because that's historical data, we see that whether someone has churned in the past or not. So now we're going to build a model that can predict on top of this data set that we have from that we have collected and historically. And based on that, we're going to build a model that the model is going to learn the pattern and use that model to predict on an existing customer whether they are, or what is the likelihood they are going to leave the customer or change or cancel their contract. So the only thing that I need to do is select that I'm going to create a predictive model here. I need to specify the target column, which in this case, it was churn, meaning that I want to predict churn. That's all I needed to do. The rest, all the settings, everything has been picked by the platform, with, in this case, Jolas AI for me. And based on best practices, based on the data set that I have or use case that I set, me as a user, I don't really need to interact too much with it. Just need to point the data set, the target column, and then hit launch experiment and go create an experiment. For advanced users, obviously, there is expert setting that they can go and interact with it. But for now, let's dial down these settings to make a very simple model. So I'm reducing accuracy because we don't care at this point in time. Accuracy, we just want to make quickly a model that we can use in our application. As soon as I hit launch experiment, it looks into data. If there is certain things that could be fixed, it notifies the user. So everything else from now on is automated, right? So I'm just sitting behind, I'm just looking what platform does for me, and starting from the data set that I've just given it. Till it creates the model and prepares that for me to go ahead and deploy it. And I don't need to borrow too much what kind of algorithm now I need to use for this modeling technique, or what kind of modeling technique I need to use for this specific use case, and how I need to prepare my data set that fits into this specific algorithm or that specific algorithm. All these steps are automated. So I just need to look at the results and try to make sense of it. That's the only thing that I need to do. So the time that I typically, if I wanted to do these steps manually and write codes and do this stuff manually, now I can save the time and spend more understanding the business part of it, or a more holistic view of this use case. Now I know what kind of features has more impact or has more signal in it, and I investigate that and spend time in those areas rather than figuring out how to write this specific algorithm, how to use that one. and et cetera, et cetera. So that saves a lot of time, and scales. It can scale the organization really high, and increase the productivity of the data science teams, actually, right? So it gives me here, for example, as the model creation, basically progress. This gives me each of the columns, or the combination of the columns. There's signals in it, and in data science, it's known as variable importance. And on the right, I see the goodness of the model, how good this model is, since it's just started to build the model. So at the end, when it completes, it prepares it for me so that I can go ahead and deploy it. So again, there are many things that we could have a look, but again, today we won't have time for it. But what I like to mention here is that there are different ways that we could now investigate and get more understanding of the data. So like interpret the model. This is machine learning interpretation. It's a subject for it, and we have lots of material around it. Also develop if you like to get and learn about those. But what I want to do now, since I have built my model, so the first step has been done, and now I'm moving to the second step, meaning that deploy this in an IT environment. And what I need to do, go back to the platform. Actually, I need to add this first, go back here to the project that I have. So this is a Chan project of Creator. I'm going to link that specific experiment, which is this one. I'm going to, linking that to that project that I've created, so that I can go ahead and signal to IT, now this is ready. You can go and deploy this in IT environment. So now, whoever that has access to this MLOps with the framework that basically manages the model deployment process is called MLOps. So whoever that has access to this, typically it's an IT team that takes the responsibility of productionization of these models. But what I would like to highlight is this one. This is the one that we have just created, and IT can simply go ahead and click on deploy that, and select the environment that they want, and get that deployed in environment. So as you've seen, it just was a couple of clicks, and I get this model now being prepared and launching and getting ready for our application now to use this. The point here is that, again, if I had done this manually, now IT needed to go through approval process or a review process, look at how I did the coding, whether that fits IT standards, etc., etc. That could have taken a lot of time. And I'm myself a data scientist. Not every data scientist like me, but data scientists tend to have the tendency of creating spaghetti codes, and that IT team doesn't like most of the time. And there are lots of those things that back and forth that now data science team needs to rewrite part of the code because it's not according to the IT standards. With that, when everything is streamlined and automated, so you don't have those issues, and IT team is also happy that they have a clean way of deploying and monitoring the artifacts that are being created by the team. Now that is being ready to deployment, being ready, it takes a couple of seconds to launch and warm it up. It takes a couple of seconds, but eventually when it's deployed and ready, when we click here, we get an API, an endpoint like this, so that we can use that to connect different applications, or in our case today, create our own application. So I'm going to copy that one and go ahead. And actually, this is finished the deployment, so I'm going to copy the one that we just created and go and use in a different example. So I prepared a different example here. We obviously need first to use our endpoint in that. You see there's a little bit of more coding here because I needed to read the data set. I'm reading now here from file, but you can connect it to your data lakes or data sources that you need to read from. And I'm connecting to that. And let me run this one. But there's a couple of boilerplate code here just to prepare this, but this part is where I'm going to add elements to basically expose now this model to into a web page. What we see here at this point, I'll just run it, nothing, but let's add more and more. So for example, I like to add a header in my application. So I could go simply here to this gallery and look for header example and get this done here, because obviously I've prepared myself already. I get this one here. So with this element here, I'm adding simply a header in here. So when I'm going back to my application now, I have a header here. I didn't know, again, I didn't need to write HTML, anything. I just need to say that what the title should be. I can add my own marketing stuff here, and icon or branding or anything that I like to have in my application. The next thing that I like to do, add a drop down that connects to the data source, and it shows me the list of items or the list of customers that I have now. So obviously I can go look at gallery, how it's done, and the drop down, but I have an example that I prepared here, just copying that and adding this one here. And now I'm expecting to have a drop down here, list of customers. And again, what I like to show here is that there is not much really that I've done here. It just said that, okay, now load drop down with the data set I've just loaded, and it goes ahead, it creates for me a drop down like this that I can do the search in it, for search it, select it, and I can enable multi-select, single select, and goes those type of stuff without any doing lots of coding. Again, this is another example. And then what I obviously want to look at is that for every customer that I select, I want to see their likelihood of churn. So what I could use is the this profile element. I've again prepared that one. Let me go get this one. So I'm copying and pasting that one here. Now, if I go here, I'm expecting to see now a user profile by pointing to the data and highlighting here the likelihood of churn. As you can see here, when I change this here, now the business user actually can start now using this. So what it does, this application actually, now quickly what we've done, it uses the models that we have created, deployed, and it uses that model now to run, send the data of that specific person and get back the likelihood of this person having a probability of likelihood of churn from that model. So we quickly have been able to get from creating model to creating an application where the business user can interact with and look at various information like that's George Eddy, that was the last marketing that what we've done, and this is the probability of likelihood of the churn, and so on. So I can add more or change this depending on what really I like to the business to see, or even speaking to them that what they really need to see. And that was the example that I created just together in a couple of minutes. But obviously in the real case, you want to have more elements. The process would look like the same. The only thing that I need to is adding different elements, and like this one, this is you use the same model. It's again churn, and we see the likelihood of churn, and a little bit more information because I've added more elements here and used also a little bit of different style in here. So it's all the way that I've done the same. You can do it here. And also add more interactivity here. So like, the business user now can use this predictive model that have been deployed, and this application now interact. Okay, that's the likelihood of, that this lady is going to churn. But what if I, reduce the price, what I can expect now? So it didn't change more, but still reduce the probability of likelihood. So they can understand a little bit by changing some of these values, or running a what if analysis and see that, how this impact the likelihood of churn in that case or any other use cases. So if here is another example from a different types of industry, like predictive maintenance, and what we wanted to do, predict the likelihood of failure in an equipment. So now what we have here is again the same. I'm just adding different components here, and in monitoring whether an engine is going to fail or any of these engines. I know, like here, we are monitoring different engines, and we're going to see that based off this sensor data that could stream into the application and run through the model, what would be the likelihood if that engine is going to fail in the next couple of days or hours, or depending on the model that we are creating, and having this real-time monitoring on equipment. Sorry. And not only that, but also go a little bit further and drill down, because I just quickly highlight that when we create a model, we can get also interpretability. Now we can expose even more information to business users, or like to engineers in that case, is that when this component is, for example, is going to break down, and we see that they are in that level, like in the critical situation, it may fail anytime soon. It just in the verge of fail actually. From the sensor data that we are collecting, where we need to look at, and the machine learning interpretability basically here also exposes this information that we can show to the relevant users that it seems that sensor 11 maximum amplitude is the high, or also sensor 4 max amplitude, these two contributing the highest on this specific prediction, so that now engineers have a starting point to look at what could go wrong in that specific. So now what I wanted to mention actually here is that what we've done today is that from the first step that we mentioned, creating a model, deploying them, onto bringing that to a business user, we are closing the entire cycle of AI app creation. And so now, by giving access to the predictive models that's been created by data science team to the business users, we're expecting now the business being impacted by it, right? So the decisions that we make now being being supported by these predictive models. And we are obviously expecting now that getting return on investment that we've done on creating data centers, creating this analytics team, by giving these kind of opportunities to business to interact with these AI applications in a short amount of time. And also, this is very important because we have been able to create quickly these applications. We get feedback from business quickly, and we do direct the entire the lifetime of these kind of applications when we're creating them in a direction that is more relevant to business. So that is actually what I wanted to cover for today. So let's go back and summarize quickly what we have done, or what we've spoken today. We, again, as mentioned, we covered that how automation and low code or no code can boost these from starting building model to delivering value to business using an Wave, which is based on Python or R, so that it can be picked up by data science team quite quickly. It has a seamless integration with HTO platform, which allows us to get up and running quickly and being accessible to business quite in a short amount of time. It supports real-time type of use cases. It runs on the cloud, on premises, depending on really where you want. And yeah, by bringing low-code an environment in the development team, we are simplifying the process so that it gives opportunity to to a broader team to get started, create those kind of applications. So if you wanted to try it out on your own, you are very welcome to go to that link here and try it out and impress us with what you do on our platform. with that, I'd like to open the session for Q&A.
Great, thanks, Asghar. So if you have any questions, please send them in the Q&A box. We already received a few, so I just start with these. Asghar, who is the target audience of the WAVE framework?
That's a good question. I mean, you need a familiarity with Python and R, and which typically you will find it in an environment where you have like data teams and data scientists or business analysts that they're working with data and familiar with how to manipulate data. So if they have a basic level of knowledge in Python or R, they could quickly pick this up and start building their own application.
Okay, thanks. How can we start using WAVE, and can I develop apps on my laptop?
But that is definitely possible, because there's two pieces here. One is creating those applications using these SDK that can be done anywhere. And you can again, let me quickly show that here. So you can go here and download it. You can run it on your laptop wherever you like I did here. So this would be available to anyone, again, as mentioned, because that's open source. Creating and running on your laptop again is possible. However, if you want to benefit from enterprise grade deployment, creating security and those stuff and running in platforms, creating an app store like this is where then you require H2A or hybrid cloud.
Great, thanks. Another question came in. Do the users need to deploy the application themselves?
That's a good question. If you're running on your laptop, that's a simpler thing of running this as I click in here and it runs it. So that's really done easy also if you're running on your laptop. If you wanted to run it on our platform, like on H2A or hybrid cloud, there are CLIs that could support you to automate the process, or you can go to the interface of the platform and upload it directly in here from your laptop to run it.
Okay. We had a question from Antimo. What exactly do you mean with real-time web apps? Could you give a real example?
Yeah, so that's a good question. For example, this one, if we look at this, it depends on really how we define being real time. But sometimes like predictive maintenance. So we want to, if we see that if the model predicts that an equipment is going to fail in next hour or something, so we need to be constantly monitoring that. So that's a little bit loose real time, but there are situations where we have fraud detection or those kind of stuff, which in a second you need to, or less than a second, you need to identify when a fraud is happening and react to it if you need it. So these are the situations where you need to quickly monitor constantly, meaning that as a transaction like the credit card payments go through, you need to monitor that and predict whether that's going to be a fraudulent transaction or it's an okay transaction. And based on that, then you need to react to it, either that block that and report that to a person to manually review that, or whatever that you want to do. But you need to track those transactions in real time in order to be able to do make sure that in terms of fraudulent in terms of credit card payment, you want to make sure that you're blocking any fraudulent transaction in the right time before a transaction goes through.
Okay, thank you, Asghar. Could you comment on the connection between Wave and MLOps?
Yeah, so Wave is where you create your UI or applications, right? And that's Wave is a tool to expose some kind of UI to a user. MLOps is where you run your model. So when you create your model, you want to have an environment where your model's been deployed, monitored, and the health of your model's being checked constantly and reported if there is something wrong with that model. So, and also exposes an endpoint where different applications now can use that endpoint to get the prediction from the model that you have and runs in that environment. So basically, MLOps is an environment where your models run, and now a Wave application could actually use that model to expose the right information to end user.
Okay, thanks, Asghar. I don't think we have any other question today. If you think of a question, feel free to reach out to us, or if you just want to continue the conversation, we'll be happy to. Thank you, Asghar, for taking the time today, and thank you to everyone who joined us. We would love to get your feedback on this webinar and the next topics you would like us to cover, so please answer the quick survey that will show up after we close the event. We hope you enjoyed the presentation. Stay tuned for upcoming events and have a great day.
Thanks, everyone, for the time. It's been a day.
Thank you. Bye.
Bye-bye.